So, welcome everyone to NetApp on NetApp EMEA. Today, we are going to be talking about Data Infrastructure Insights and Kubernetes. And we are joined by Kishan K.S, Information Systems Engineer, and David Fox, Platform Engineering Team Lead. And they will shortly begin talking. First, I just want to go over some ground rules. Please use the Q&A function if you have any questions. We will answer them either during the presentation or afterwards. We'd really love to see them. Also, when today's webinar is over, the recording will be available shortly after, and there will also be a questionnaire. So please do fill that out if you have any thoughts about today's webinar, what we did right, what we did wrong, any kind of feedback you may have. And that is it for today. So we will be kicking off with Kishan.
Yep. Okay, so are you guys able to see my screen?
Yes, I can see your screen. Thanks.
All right. So good morning and good evening, everyone. Today we're going to talk about Data Infrastructure Insight, formerly known as Cloud Insight. It's a monitoring tool which gives a visibility into your entire infrastructure. So we are the NetApp IT DevOps team. Like we've been using Data Infrastructure Insight for about year and a half now, and we're going to talk about like our experience, using this tool and how it is benefited us. What are the features we've been heavily using from this tool, etc. So a quick introduction to ourselves, like we have David Fox, he's a platform engineering team lead. He's expertised in Kubernetes and Ansible. He's been with NetApp for quite some time now, and with NetApp IT DevOps team, he's been there from the starting. So the next slides, he's going to talk about our cloud journey and DevOps journey. So he's going to do that. And myself, I'm Kishan. I'm an information system engineer. I take care of CI/CD part of it and automation and monitoring tools. So yeah, in this today's webinar, like Dave is going to talk about the roadmap to our cloud adaptation, our journey of the DevOps, and is going to talk briefly about Kubernetes and what role does it play in the process, what are the challenges we face in our DevOps environment, and how DIA address these challenges, and also we're going to talk in detail about the features and functionalities of the Data Infrastructure Insight tool. With that, I'll hand over to Dave. Dave?
Cool deal. Thank you. Okay, so just to lay a little bit of groundwork on where we're at and how we got here, I think it's important to talk a little bit about the past. So when I first started at NetApp in 2014, we were running our IT operations and engineering almost like in that 2000s type of style, where if you were an application team, and you had this new application that you wanted to deploy, you would talk to someone like a domain architect, and that person would gather all the teams together, from compute, from storage, from networking, from security, whomever, right? And you'd lay out what your requirements are, and then everybody would sort of kind of go their own separate ways, and then eventually, and that time was often measured in at best weeks, sometimes months, you as the application owner would get the infrastructure that you needed so that you could start deploying your application. Obviously, this wasn't ideal. It was very slow, very tedious, very error prone, right? And so a lot of teams started doing what I would call automation in silos, right? So, fast forward, a year or two, and we still have that same process where if you needed, infrastructure for your application, you would still, talk to the domain architect. Teams to still come together, figure out what everybody needs, and then okay, we go off and we do our thing, but we'd have that our individual pieces automated, right? So we saw a lot of efficiency gains when we did that, But it was still somewhat slow and tedious, right? You still had to have a meeting. People were still, doing their things in an automated way, but you had to put it together in sort of what I would call like a semi-automatic fashion, right? And so, you know, still it's an improvement, but not where we want to be. And so, fast forward several years, Kubernetes becomes a thing. Containers are starting to get, wide adoption, and we invest heavily starting in 2017 into Kubernetes. And so that has really brought us to where we're at today through multiple iterations with what we would call our NetApp hybrid cloud, right? And the tenet of this hybrid cloud is that everything should be self-service, everything should be automated, and we want and have taken what was a very manual process that took weeks or months and shrunk that down to minutes. And the outcomes are utterly consistent, right? So, with this NetApp hybrid cloud, we were able to shrink what we were doing in months, shrinking it down to minutes. Next slide, please. And it sort of kind of begs the question, well, why did we make this change? Why the need for speed, right? Well, obviously everybody always wants things, faster than what they get them. But it was really the hyperscalers, people like Amazon, people like Google, people like Microsoft, right? That sort of kind of changed the expectations that our application owners had, right? They wanted something, self-service, right? They wanted, it to be simple, and they wanted to be able to get what they needed at the time they needed it, right? And so that's sort of kind of the experience that we wanted to build in-house, right? So we've taken our offering, put it behind a self-service portal, and then you as an application owner really get to choose like the basic building blocks of what your application needs, right? So my application stack is going to consist of Angular JS and MongoDB, and I need this much storage, I need this much compute, and it should be exposed with this host name, right? So we take care of all that for people, right? And we do it in such a way where the individual or individuals that are requesting this type of service don't really have to know about the infrastructure, right? They don't have to care about, oh, is this compute running on-prem? Is it running AWS? Do I have to do things differently over here than over there? We made a very cloud agnostic solution where people sort of have that complexity abstracted away from them, right? And then from our perspective as an IT infrastructure team, it's completely hands off, right? So, we've enabled our end users to get what they need when they need it, and we don't have to manually intervene anymore like we did in the past, right? So everybody's winning with this new, sort of kind of self-service model that we iterated over many years. Next slide, please. And really, when you think about it, what we've delivered is sort of kind of like DevOps as a service, right? So you come into that self-service portal that I described, right? And when you request your application stack, you're not just getting that cloud compute or on-prem compute that you need to host your application. You're getting all the other stuff that comes with that, right? You're getting a CI/CD pipeline. You're getting entries in CMDB. You're getting disaster recovery as a service, right? And again, as I stated in the previous slide, this is done in a very cloud agnostic way, right? And a lot of teams don't know and really don't care where their application runs, right? They just want it to run. And so with this DevOps as a service solution that we have, which is really, the linchpin for our hybrid cloud offering, people are getting everything that they need, not just somewhere to run their application, but somewhere to store the code, a way to do security scanning, logging, monitoring, et cetera, et cetera. All of that comes out of the box with our in-house solution. Next slide, please. And, speaking of Kubernetes, which I mentioned earlier, we really started investing heavily on in 2017. Kubernetes is really the new operating system for the cloud, right? The latest data that I pulled was from 2022, and you can see like the big difference in 2021 and 2022 in terms of adoption of Kubernetes. And people are adopting it because it's really a declarative way of deploying your application. You don't have to, go manually tweak configuration files, et cetera, et cetera. You just say, here are my images, here are my artifacts, go. And it just runs, right? And so that really, appeals to application developers because, they don't have to worry about the care and feeding of a VM, the patching and all that, overhead, right? They've just got artifacts and configuration files, and all that's driven through a ci pipeline, and then the infrastructure piece, that's what my team takes care of, so other people don't have to, right? And we've seen this adoption grow even more from 2022. I mean, just speaking with customers and executive briefings, birds of a feather meetings, everybody's jumping on Kubernetes. Kubernetes is the way to go. It's seeing that adoption, and it really is the must-have feature for any hybrid cloud operations team, right? But with Kubernetes comes some unique challenges, right? So next slide, please. Kishan, I'll hand that to you.
Yeah. Thank you, Dave. Kubernetes can be, complex, right? So it can get complicated, involved in a lot of tools. Kubernetes made of a lot of tools together to make it as a platform. There is Jenkins, there's Service Mesh, kubectl, STO, Git, etc., etc. And also it's a hard to find skill. One of the major challenges what we see in our day-to-day life, working life is like unexpected changes and misconfiguration done by either a developers or our platform engineers itself. So unexpectedly making those changes and resulting in application downtime and impacting the business. So and also like solving this problem requires understanding of all Kubernetes components and underlying compute and storage information. So yeah, this complexity resulted in operational inefficiencies, troubleshooting delays, and increased expense. So these are the some of the challenges are seen by multiple teams involved in DevOps. Right? For example, our L1 and L2s, like they get so many incidents. Most of them, some of them are like false positives, and developer engineering team, they spend so much time on reacting to service disruptions and downtime. They invest their time in that. And also for a developer, you need to provide a tool for troubleshooting, right? I mean, with a one glance, one view, he should be able to see like, oh, is my application running healthy, is my pods are healthy, like if there is any like errors, is there any alerts, what is my utilization, etc., etc. We need to have that. So including because of multiple tools involved in here, so he doesn't get that, right? So, and also for a manager perspective, since we are working in a hybrid cloud, and most of our workload runs in EKS, so he needs to have that clear picture of utilization, and so that right sizing is happening or not. What is the resource being assigned, allocated to my clusters, and etc. So these are the some of the challenges each team has, and yeah, I mean, data infrastructure insight comes in play with that, right? So what if from all these tools you send the data to a centralized tool where from all these two teams can analyze the data and gets the benefit out of it, right? So in the coming slide, I'm going to talk about these features and mainly the change analysis feature, which has been really helpful for us. Yeah, for any monitoring tool, the basic functionality should be monitoring the health of your workload, right? And DI does it wonderfully well. So also like if you are an application owner and you manage a multiple application, you just have to log into a DI portal, and you get to see your workload health in a one view. And also you can drop down by your application name or namespaces or a workload. It gives you that flexibility. Another key feature what DI provide, and we use it really well, is that planning the capacity management. For example, we we provide an option for our application team to when they onboard their application, they can choose a t-shirt size namespaces, right? There is small, which comes with, let's say, 6 CPUs and 512 MB of memory. Then there is medium, there is large, well, XL, etc. So that, like, how much are they using it? Are they using it in the right way? Are they overutilized? Are they underutilized? So these kind of data, so BI does provide us really well. And also for a particular workload, how much CPU limit has been assigned, how much request has been assigned. So what is the range is being used, like, and also it uses this machine learning capacity to gives us and also predict what should be the value you should be assigning. So it gives that recommendation as well, which we have been using it. Um, yeah, and also, like, as I mentioned, like, you can it gives you a one view picture of your application and your cluster. So with that, troubleshooting gets much easier. So if you see, like, if any in the screenshot, you can see if there is any alert in a workload, it highlights you so that you can go and work on to fix it. Next is workload map. This is also a really nice feature, right? So for let's say you have an application with UI and API and a database in it. Like, so these are all dependent to each other, right? So DI gives you that the workload map. It gives you, like, what are these, how these services are interconnected, and what is the traffic, which service is the source of the traffic, and is there any latency between in these services. And also sometimes what happens, one service is up, another service is down. Like, you check a service which are healthy, and you start wondering why my application not working. So this view gives you, like, all your dependent services and the network map. With that, you can analyze, like, where what's going wrong as well. And also, like, if there is any high latencies, your performance gets degraded, right? So with this data, you'll be able to tell, like, if there is any network latency in between these services. Yeah, and the next is Kubernetes topology, right? As a platform engineer, like, we need to know the health of our cluster. So, and this one single panel of a dashboard tells us, like, whether not only just my cluster is healthy, it also tells, like, how many nodes are assigned to this cluster. How in those nodes, how many are healthy, how many are not healthy, how many parts are running, and what is the CPU has been allocated to this, and how much is the utilized. So with this data, you can take some decision to, like, shrink your CPU memory or storage allocation, or, like, expand it based on the requirement, right? And also you can drill down to unhealthy nodes and see the alerts. And also you can drill down to the workloads running in those nodes. If there is unhealthy, what are the event, when it was caused, etc., etc. So this is a really cool and need to have feature we get in DII. Another is the change analysis. This has been really helpful, and this has been the game changer in terms of troubleshooting, right? So in the previous slide, I talked about the misconfiguration, or, like, an unexpected changes done by either an developer, or a platform engineer when we're doing the deployment, right? I'll give an example. So let's say my workload required CPU limit of 500 MB, right? So it has been running. We accidentally we misconfigured it to 300 and deploy an application. So it ends up in pod crash loopback error. So I mean, as a developer, like, we are not really sure. And also, like, with the day, what changed? Because my source, everything looks good. Why my pod is not coming up? So with this change analysis feature, so DII keep tracks of the each manifest was deployed, right? So what was the deployment, what is the time the deployment was made, and was there any changes being made? Like if there is any change being made, like what are those changes? So with that, and also you can correlate that change with the alerts and logs as well. So you select a workload and a time frame, and there's a green button in the you can see in that screenshot that tells you about the deployment, and was there what are the events generated during that time. and uh, uh, and also you can map it with the other services deployment as well. So from the same namespace you can select the other workload running, and you can connect whether there was a deployment made or not, and if that was there any the deployment is successful or not. So these are the analysis will help us and also developer to like know troubleshooting if there are any outages. Another thing is like I mean any monitoring tools like today's world don't need to have is a dashboard, right? So DI is no exception of that. So it by default it gives us some dashboards like which are really helpful. I can give example like Kubernetes IT operations, meaning it in a one dashboard it tells you like how many clusters are there, how many nodes are there, how many unhealthy, how many active alerts, how many events have been generated, how many workload is running, how many are daemon sets, how many are replica sets, how many are stateful set, etc., etc. So these and also like cost analysis, meaning uh, you can arrange them in ascending or descending order, like in our entire workload. So which is the culprit which are like highly used, like have highly underused. So when you work with a respective team, you can actually target that and you can save a lot of resources there. So we did that in one of our exercise we conducted some time ago. So yeah, I mean, so and also like which are like under provision. So that dashboard has been helpful. Then the important thing is like we can create our own custom dashboards. Meaning like I'll give you an example. We created something called namespace specific, which has been really helpful. So as an drill down, you can select your application, you can select your namespace, and with if you select a namespace in a one panel, you will get all the need to know details, like in which node it is running, which cluster it is running, was there any changes being done to this workload, was there any alert triggered, was there any event generated, if there is any, how many workload are running, how many have been restarted in last, like you can select the time frame. So with one panel you get all those details, so which has been really helpful while you're doing the troubleshooting. And from there, if you need more details, you can just drill down to next pages to get more details. um, yeah, with this, I'll tell you like another thing which we found it really easy was like installation, right? You may be wondering how data infrastructure gathering the data from all this cluster. So it's because of the small lightweight operator DI provide, which is called NKMO, NetApp Kubernetes Monitoring Operator, which is really simple and easy to install. We install in its own namespace, and it comes up with some daemon sets and some replicas. Example, Telegraph, and there is Cube System Metrics, then Fluentd, and Change Manager, etc. These are the some of the services which keeps track of all the transaction happening in your clusters, and it sends the data over to a DI to monitor and analyze those data. So that's how it's being done. And yeah, it comes with 4 dashboards, and we created about 20, 30 dashboards as we needed. right? And it's their documentation has been really good, and we are able to create them pretty quickly. Another very basic and must-have features are like alerts and rules. Like one cool feature we found was like it comes but default alerting, like so there are about 30-40 alert, it automatically comes with it, so we just had to enable it or tweak it to our needed. And also plus if you need more, like we had created our own metrics, and it's been simple, right? So be it your performance metrics or downtime, you are like pod crash loopback error, image pullback error, your just an examples, CPU saturation, memory saturation, etc., etc. So all these alerts we were able to configure, and it's been helpful for us. Um, yeah, with that, some of the key takeaways are like Dave talked about our cloud adaptation and our journey so far in our DevOps, and what are the challenges we have seen in our DevOps, and how DI has been able to help us, resolve these challenges. Uh, yeah, I mean, with that, do we have any questions?
Yeah, so a few questions. Um, you mentioned that moving from manual provisioning to a DevOps as a service model drastically reduced delivery time. What were the key turning points or lessons learned that helped you accelerate that transformation?
I can take that one. I think the key lesson learned was start somewhere, right? So for a very long time, there was almost this analysis paralysis where it's like,
Mm,
oh wow, there's so much to automate. Where do we start? And for a long time, it was, it just became this situation where nobody could agree, like, on where to start or what the end product looks like or anything like that. And so eventually, groups of people just started doing automation, sort of kind of in their own space, right? Um, but that provided a springboard into a more holistic solution, right? So once we broke out of that analysis paralysis and started just somewhere, right? We were able to land and expand, right? And and really once we started doing that, everything else just sort of kind of took off and fell in place.
that sounds great. Yeah, so we have another question here. Sorry, I'm multitasking here. Can you share a specific example of how DII's change analysis or workload map features helped you identify and resolve a real-world issue faster than before?
Yeah, sure. I can take that one. So yeah, so the one example I can think of is like in the recently it has happened, and it happens like pretty on a regular basis. Is like we are adjusting the CPUs and memory, and we're not sure sometimes like. We make that changes, right, in the CPU limit and memory limit. So and then the recent example we saw, like in that particular workload needed a 500 MB of CPU, but the user had adjusted it to 300. It was running for some time because during that peak hour, it was hitting that limit, right? It has pumped up to 500. It needed more, and their pods started failing, and they were like wondering why, because it was running for some time, suddenly what happened. So with this one, like after that workload comes down and the pod was automatically restarted, and it keeps doing that in the regular time. So then we traced back to that the particular change made by an engineer to adjust it, that was a culprit. So we had to revert the change to the original one. Then the load is being matched pretty accurately. Then never after that, like due to that issue, that restart was happened. That was the one thing. And other thing, like I mean in the team, that's about the change analysis. The mapping is, yeah, I mean the performance, right? So the recently we have seen one of the due to some issues, like there were within the services there was some delays. So with the tracking back was really hard. So with this the workload map, we were able to tell the delay, right? So with that, we were able
Mm.
to work with the respective team to fix that. So there are a lot of example like that. So it happens quite regularly. But yeah, DI has been really helpful in addressing those challenges.
Yeah, it's a very powerful and flexible tool, certainly. So I just have one final question. How do you see automation, AI, or right-sizing capabilities evolving within your Kubernetes operations?
So I could take that. So we had a slide earlier where we talked about our journey. And, the journey isn't really premised on a destination, right? It's premised on a direction to move forward, right? And so our automation is constantly changing. We're constantly making improvements to either, the platform automation or CI/CD automation or, any of the various other automations that we have to make our solution that we offer to, our internal IT application developers to make it more robust, to make it with more service offerings, to allow easier triage, problem identification, et cetera, right? And so I really see that trend continuing, especially with AI,
Mm.
which I really see as sort of kind of like the next step in automation when you think about it. It's going to allow us to shift even further left. I think to a certain extent, if you recall some of the slides that we spoke to earlier, you know, one of the things that we really tried to strive to do is, abstract away the complexity from the end user, right? And so, you don't, as an application owner, necessarily need to be a Kubernetes expert. It certainly helps, but you don't have to be, right? But as part of
Mm.
that, what we've discovered is that if you don't have to be a Kubernetes expert, you might not be a Kubernetes expert. And so then, when challenges come up, when problems come up, such as, where is this error in my application coming from, right? Why am I seeing these random timeouts? That kind of thing. Honestly, I see AI uh, helping us to push that initial triage of problem determination, as far to the left as possible, all the way out to the application owner. Whereas now, if they see one of those problems, they might ask somebody, operations or engineering, assuming they can't, quickly identify in DII, which is, increasingly not the case, right? But, there are some corner cases, where it's like, just like, help me improve my application. How can I make it perform better, right?
Mm.
Um, you know, in those situations, instead of reaching out to, an expert, as it were, right? They can ask an AI agent themselves, hey, go look at my application. Tell me what I could do better. Tell me why I'm seeing this error, and be able to get like an expert opinion more quickly than they could if they were to say submit a ticket or, wait for somebody to come online because, they're in one time zone and, the expert they
Yeah.
need's another time zone. So I think those are going to be some pretty big trends.
Yeah, I mean, the idea of an AI chatbot that could help you with those kinds of things would be amazing because, you could keep tweaking and get those answers much faster than a ticket-based system, like you say, with the different time zones. So that's a good idea, certainly. We do have one question. Can DII alert on Trident Protect SnapMare app replication issues?
Um, Right now, we are not using that, but I'll have to check that out. Right now, what we are using is like in terms of Trident, we are only monitoring the Trident processes, like the Trident pod, and also that the path to the PV and PVC. So that is something we are using at the moment today. So also like in the Kubernetes. So I'll have to check that one. So if
Okay.
the AI can do that, yeah.
Yeah, I've saved your name, Duresh, so I can share the answer once we get it for you. Okay, so if anyone has any final questions, please let us know. Otherwise, we'll be wrapping it up. Thank you very much, Kishan and David, for sharing with us this presentation. I believe, Kishan, the QR code is for feedback on DII.
Yep.
Great. Okay. So I'll give you a minute, scan the QR code or contact NetApp this way. And if you have any feedback, otherwise, we will have a survey popping up. Please answer that if you can. It's greatly appreciated. It helps us improve and helps us pick our next topics. And thank you everyone for joining us. You will shortly receive a recording of this webinar, and we'll see you again next time.